In this question, we have a circuit as shown in figure. A voltmeter has a resistance of 400 ohm. That is, let's say RV is 400 ohm, and we have to calculate the potential difference across 100 ohm resistor. So what we'll do is, let's suppose that current I is coming out of the battery. So first of all, we calculate R equivalent. So to calculate the R equivalent, we have 100 ohm in parallel with 400 ohm. So let us say R dash equivalent is 1 divided by 1 by 100 plus 1 by 400. That comes out to be 100 into 400 divided by 500. So it comes out to be 80 ohms. 80 ohms is in series with this 200 ohm. So our R equivalent comes out to be 80 ohm plus 200, that comes out to be 280 ohms. This is our net resistance. So current can be easily calculated by Ohm's law, that is V is equals to IR. So I have potential as 84 volts, current is I have to calculate, and resistance is 280 ohms. So current comes out to be 0.3 amperes. Now this is the current coming in this branch, that is 0.3 ampere. This 0.3 ampere will be divided in these two branches. Let's say current going through 100 ohm resistor is I. So the current that is flowing through voltmeter will be 0.3 minus I. Now since between this point, that is 0.1 and 0.2, the potential difference will be same, since 100 ohm and voltmeter are in parallel, so I can write potential through 100 ohm is equals to potential drop across voltmeter. So I have current I into resistor 100 is equals to 0.3 minus I into resistance of voltmeter, that is 400 ohm. So I have 0.3 into 400 minus 400I is equals to 100I. 500I is equals to 0.3 into 400. On solving this equation for I get the value of I as 0.24 amperes. Since I got the current that is flowing through 100 ohm resistor, I can calculate the potential drop across 100 ohm resistor, that is 0.24 into 100, that gives me 24 volt. Now this is the potential drop across 100 ohm, and since this resistor 100 ohm and voltmeter are in parallel, so the voltmeter reading will be equal to 24 volts. That is the answer for the first part. In second part, we had to calculate the potential difference across 100 ohm before the voltmeter was connected. Now since voltmeter was not connected earlier, our R equivalent will be simply 100 plus 200, because these two resistors are in series. So I have net resistance as 300 ohm. So net current flowing will be V by R, that is 84 volts divided by 300. That comes out to be 0.28 ampere. So the potential drop across 100 ohm resistor can be calculated by V is equal to IR, that is I is 0.28, resistor is 100, that gives me reading 28 volts. That is the answer.